Okay, you're on.
Let's check that we're actually on.
Yeah. Use this.
Okay.
Okay, no one here, I think, but fine. Okay, welcome everyone. This time for real, I hope. Welcome to the September 2017 edition of the GRR meetup. Today we're going to talk a bit about the server release we did 2 weeks ago. The new version is 3.2.01. And we are presenting today live from Zurich. I have the whole GRR team here, which is Misha, Denver, Ben, and Milos. My name is Andy, and we also have actual GRR users here in the room with us, which is super cool. Okay, so quick, the agenda for today. You probably already saw it earlier, so I'm just gonna open this up. So we're gonna quickly talk about the new GRR release and testing process that we have and what it allows us to do in the future. We're gonna tell you a bit about the new GRR server and clients release schedule. It's gonna be much faster than before. And then we have one slide about output plugin changes that we did in the new server. We have that change on today because we received some bug reports. People had actual issues with that. The new system is easier to use, but we have to kind of explain it once, just so there's no confusion. Then we're going to talk quickly about the recall and the WinPMM support in GRR. That has changed a bit. We talked about this in the last meetup already a bit, but there has been some new events. And then I'm going to tell a bit about the GRR memory forensics roadmap, very much related to the recall support that we speak before. In the end, we're going to have data store layer refactoring. If you remember from last meetup, we had the plan to make a big change in the GRR data store. And today we're going to tell you a bit what the process has been there. And then last but not least, we're going to talk a bit about FleetSpeak, which is, as I'm sure you all remember, the new communications layer that we will have GRR running on in the future. In the end, we will have a long, hopefully, Q&A session. If you have questions, please join our Gitter chat. The URL is there. It's gitter.im/google/GRR. And with that, I think we'll jump right in. I'm going to hand over to Misha, who will tell you a bit about the release process.
So we have a new automated GRR release process. What this means is that now, after every commit push to GitHub, we build a new server dep with all the client templates included. So this means that you can pretty much get this dep and install it, and it will work. And it will be the latest current version of GRR. This differs significantly from the process we had before, when we had to build GRR server deps and clients by hand. And so what this means is that we think that we will be able to do releases more often. Thanks to these automated builds, we will effectively periodically pick the current stable build and run it for end-to-end tests and mark it as a release candidate. So our goal is to approximately release quarterly, but what we definitely want to avoid is releasing like once a year, like we did before. So there is a link in this slide. This is a location on Google Cloud Storage where the current successful GRR build is pushed. It is pushed there on every successful commit. So now if you want to track head, it's probably much easier to do that than before with this. So I'll move to the next topic, which is output plugins changes. So this is a change that came with the latest release 3.2.01. And what this change is about is that we deprecated the CSV output plugin. For the context, before, when you wanted to have CSV output, you had to, when creating flow or hunt, you had to add a CSV output plugin, and then you had a bunch of links in the UI with the generated CSV files. So now that's no longer needed. Whenever you go to results page of a flow or a hunt, there will be a download as block on that page, and you then can use it to download the results in CSV, YAML, or SQLite format. SQLite format here is particularly exciting because this means that you can pretty much download all the results and feed them into the SQLite database, and then like easily query them. So due to this new functionality, the old plugin is deprecated. So yeah, that's
obsolete and deprecated.
Yeah.
Okay, thank you. Okay, the next topic we want to cover today is the recall support. We have talked about this in the last meetup. Michael Cohen, who is supporting recall, has left the GRR team. He moved on to the cloud. And since then, recall support in GRR is a bit flaky and unstable. On top of that, we have identified some stability issues in the WinPMM driver that has led to some blue screens of boxes in our environment. And that, combined with the fact that recall support is basically non-existent on Mac and Linux at the moment, we have decided that we will disable recall by default in GRR. So if you still want to use it, you can. It's only a config option that you need to change. It's I think it's called recall enabled. It's true. You have to just add that to your config file, and everything will work as before. But you have to realize that at this point, there will be no recall updates in GRR. And if anything breaks, we are not going to fix it. Knowing recall, things move really fast and things break all the time. So I would say it's just a matter of time. If you really, really need recall, don't rely on it being in GRR. Having said that, we know that memory forensics is a big topic and everyone wants to use it. So we have to find a way to make GRR do it still without recall. One of the most popular features is GRR scan. And we are going to have that implemented very soon. It's actually, we pushed the first shot at this flow to GitHub yesterday. And what this is going to do, it's going to do GRR scans on process memory instead of physical memory as we did before. The pros for this is very obvious. We don't have to rely on recall. That is a huge plus for us because recall changes a lot and we would have to keep up all the time. And second, we don't need a kernel driver for this. Why haven't we done this before? Well, there are also cons. The first one is that we can't scan kernel memory itself. We're not allowed to do that as an unprivileged process, not a driver. And some processes are also restricted, so we can't attach them as a debug interface. Nevertheless, we have something and we provide that functionality. Now that we have GRR implemented in that way, or that we have GRR in GRR in that way, we will also probably provide functionality to use GRR for other things like scanning files in the future. Then the next thing I wanted to talk about is the data store layer refactoring. We have said that last meetup already. We wanted to go with our data store to a model that is more suitable to, I would say, MySQL in the open source world. So it would be a relational data scheme. And we have started doing some work on that. Of course, it takes longer than expected, as always. But our main goal is still to have a SQL-friendly data store. The problem is that at the moment, we have a lot of different data store implementations that we have to maintain. So every change takes some time and effort. And therefore, we will, in the future, deprecate the HTTP data store, which is the distributed SQLite data store. We're not going to deprecate the SQLite data store just yet, because it's very useful to do a quick demo and a fast spin-up of GRR. But the HTTP data store at this point is probably too much effort for us to maintain and convert to the new format. It's not going to work that well. The MySQL data store that we have is the current production level data store. And we're going to make that probably, if we can, much faster than what we have today. So that's the plus. And then we hope that no one would have to use the HTTP data store anymore. That's the current status of it. And then I'm going to ask Ben to talk a bit about FleetSpeak.
Right. So FleetSpeak has been said before, is our new communications approach to GRR. So we're moving in this direction. It's going to be a separate process, and it's engineered to be reusable in the sense that you have one process in the client. It's a bit of a hub. You can have other things that it does besides talk to GRR. Currently, we're a little heads down because somebody internally got wind of it and said, oh, yeah, we really need this, and we've been trying to get it working internally, and we're getting close to that. And then the next priority will be to get it out to you guys so that we see what you think. So currently, we'll probably have something that you can look at. It'll have a demo SQLite data store, hopefully end of year, very early next year. And then a bit later next year, we hope to have a production data store and the full proper GRR integration. I think that's the highlights. Separate process. Oh, it's written in Go instead of Python, so that is a change. It'll be using TLS, HTTPS instead of HTTP, and expects to terminate the TLS itself. So hopefully none of this is too much of a configuration change on your end, but we'll definitely take some time to try to well document it and provide a good integration with GRR when we really think it's ready for you guys next year.
Cool. Thank you. Okay, and this is already the overview of the new release that we wanted to give. And yeah, I think with that, I would say if anyone has any questions, please feel free to ask. Oh, we have to wait. Unless you have some questions.
So maybe I have a question. How's the use cases for you to use FleetSpeak at the end? And how does the use case look like? Or
do you want to take it?
So FleetSpeak, the idea is that you have a communications hub on the client and you have a communications hub on the server, and it takes care of the endpoint to server backend communications channel, and it provides a sense of identity and some security. Like it doesn't, it tries to ensure that two clients can't pretend to be each other. So if you have a secure machine that's talking to FleetSpeak, somebody can create a new machine and start talking to FleetSpeak. That's intentionally easy, but it can't be confused by the previous machine. So that's the basic functionality. And a little more detail on the client side, you have the ability we have a few different plugins you can use to connect it to other things on the client in different ways.
So predefined plugins already available.
So the idea is you have some code, which we call a factory, a service factory. You have a configuration that tells the service factory how to talk to a client process, and then that combination then. So for example, in the case of GRR, there's the FleetSpeak will execute GRR as a separate process, and so the configuration says, okay, use the mode where we execute something as a separate process, use that factory, and run this process. Here's the command and the flags. And this configuration is a signed file that FleetSpeak looks for that you install with GRR. And then it runs GRR when, currently all the time, but hopefully for the integration, only when there's actually work for GRR to do. And in the same way, you can have a configuration that says, when you get a message for this service, just run this program, take stand in from the message, take stand out and hand it back to the server, and it will just execute your program. And again, the name of the program and the flags must be in a signed configuration file.
Yeah, these signed configuration files, it's possible to push them to the clients.
Exactly. So the idea is that FleetSpeak, like the packaging structure we're using internally, is that FleetSpeak is a Debian package. It just runs the service, and then GRR is another Debian package. It contains the GRR binary and the signed configuration, which it drops into the directory that FleetSpeak looks for these. And then the next time FleetSpeak restarts, it sees that and says, "Oh, now I know how to.
Okay.
Now I know what to do with the message to GRR."
Okay, cool. So there must be predefined at the deployment of GRR. So
right. So deployment of FleetSpeak, you say, here's the key that things must be signed with, and then when you push GRR or some other service that wants to use FleetSpeak, you include a configuration file with that signature that tells FleetSpeak, hey, it's okay to talk to GRR, here's how you do it. It's okay to run this command, here's how you do it.
Okay, cool. And your internal teams has already use cases to use this mechanism for
exactly
incident response, or
so for all kinds of use cases. In the end, what you have to do is, well, what you can do with it, you can write your own agent that comes with all the features, which is like monitoring, secure communication, everything. But you don't have to write it. You just plug into FleetSpeak and you say like, all I need to do is this client code, like the actual thing that you want to do.
actions on the client.
And you don't care about anything else. You just say, send this message to the server, and then FleetSpeak will do it for you. Right? That makes it a very easy to use tool. And we hope to see many use cases of it. We'll see.
Right, so one use case that we're looking at internally is collection of logs files. So you can run an agent that collects logs files or similar continuous information, and send it through FleetSpeak. And in this way, it's not quite the GRR use case, so it's not something you want to do in GRR, but it's nice to have it use the same communication channel, so we don't have to worry about opening ports for different agents. And also, you can ask FleetSpeak what's running on this box, at least of these things, and who sent messages recently, what's going on. It also gives you an overview in that sense.
So this would also allow to use remediation mechanism through FleetSpeak.
Wanted to say, so we could integrate our stuff.
It's an easy extend.
It's intended to be a bit focused on detection and response, as we say. It's not like supposed to do full package management and so on and so forth, but it is supposed to be, a communication channel for that sort of purpose. And so,
Looking forward. Cool.
Okay, there's Hilko. Okay, so there's a question on Gitter that is basically that before we had HTTP plus encryption on top of that instead of HTTPS to avoid trouble with man-in-the-middle boxes, for example. So I agree with that. I think the main change is that since when we came up with that design, how many years have passed? Like 7 or something. And back then, HTTPS was not that common at all. It was more or less the exception. Nowadays, I think we have more sites on HTTPS than we have on HTTP, right? So proxies are much better at handling HTTPS nowadays. Of course, I mean, if you have a man-in-the-middle TLS thing, then it will break GRR, but then you can also have a man-in-the-middle HTTP thing, and it will break GRR the same way. So we are not too worried about this.
Yeah, I mean, and currently we put fairly odd-looking traffic over HTTP, whereas what FleetSpeak sends over HTTPS should be pretty hard to differentiate between any other HTTPS traffic. So at least, I mean, I'm not going out of my way to make it hard, but it's not doing anything funny at the level that I'd expect people to be trying to analyze it.
In the end, if there are too many troubles with the new protocol, then we can always just switch back to something similar. Yeah, it's not.
Yeah, I mean, FleetSpeak identifies by the key, not by a certificate. So in some sense, we'll do what we need to do to get communications.
But we'd rather not
labeled by the key. But we'd rather stop doing our own crypto as much as possible.
Maybe a question to the data store. Is it only a change of the scheme for the tables and so on of the data store, or also how you query the data internally?
Yes, everything is going to change basically. So the problem with the data store is that it's very much tailored towards what Bigtable is good at. Now that is fine for us. But of course, no one else has Bigtable at home, so everyone else has those issues. And what we are trying to do is we're trying to go to a data model that is much better for, let's say, MySQL to handle. Right? At the moment, MySQL really struggles. So we have a question here on GitHub as well. It says that with 30,000 clients, the MySQL backend doesn't seem to scale. right? And this is basically what we want to address. We want to make a data store that is more standard. It's basically something that the data store administrators have seen before, that looks like something they know, and that they know how to make fast. And this will help to eliminate all those issues. And it should just scale. You know, MySQL is not really slow. It's just slow at
some queries.
At some queries that we have that come from Bigtable, and it can't be fast at that. This is just, we know that, and we want to get rid of that. That's the idea. And we have actually seen patients that are not ours that are really scalable because they have changed all this. So we have basically just some internal details. We have changed the internal data store API already, so it's prepared for this. So at this point, you can just take some parts of the MySQL data store and store it in a different way in a table instead of the standard way that we do that is slow, and you will get speedups right away. If you know what you're doing, it's kind of easy. But the plan is that we will give a reference implementation in the future that does it. Will there be a tool for migrating the existing data to the new data store? Will there? We'll see when we get there, I guess. So we often try to be backwards compatible with GRR as much as we can. Sometimes it's hard to avoid breakage, I have to say. It depends, I guess, on which data you are interested in. If we say we want to keep the forensics data, then we can do that. If we want to keep all the data, then that's maybe a bit excessive. So maybe you will lose the information what flow ran on what client. But we can maybe convert the basic forensics information, because this is, I hope, what people care most about.
Maybe would it be an issue to lose the data?
Well, someone asked that question on GitHub, so I think for some people it might be an issue. It depends what they really care about. It doesn't specify here.
One of the alternative approaches to consider is that data can be rather easily exported from GRR. So flow, like lists of flows results, hunt results, BFS information, especially through the API, because API provides an easy way to query this data. So one of the possible approaches would be to be able to easily export the data and feed them into a conventional database, so that they can be queried and whatnot, but not necessarily backwards compatible. I wonder if that's okay for people who are concerned with backwards compatibility.
Mm-hmm.
But that's a good question that we should probably discuss on the mailing list.
Mm-hmm. Yeah, I agree. Okay, I think if there are no more questions, then we call it today. Give it 1 minute.
Yeah, let's give it a minute.
1 minute. I think memory imaging is pretty useful. Okay, so there is a question if we can keep memory imaging, because that is useful. So what we plan to do is to do imaging of process memory. So the same way we at the moment have the GRR scan of process memory supported, the idea is that you can also just dump the process memory and collect it with GRR. I assume what you're asking here on GitHub is the full memory dump of physical memory. And the problem here is that this is not doable without a driver. And if we want to do that, then we will get the same stability issues where we have crashing boxes the way we had before with recall. So this is why we don't really want to provide this. Yeah, it's a hard question. We would like to have it, it's really hard.
I think the answer is that we're not sure we have the resources to correctly validate a device driver going forward. And that's the real problem we have with physical memory capture or scanning. Like in terms of like the simple scanning, full analysis requires something like recall that has another large maintenance burden, especially recall, because you're doing something rather complex on the box. But just scanning would be simple, but maintaining the driver is not.
Yeah. And it's only going to get worse in the future. There will be new requirements by Microsoft. And yeah.
Are you in contact with other memory collecting teams or developers? So to use other memory collector tools on the box.
So we are thinking about doing that. We actually have looked at what's out there. In the end, no one can do it without a driver. So whenever we, let's say, buy a third-party solution, then we still have a driver, and we need to test this driver. We cannot just let that driver loose on the users of GRR. And the amount of testing that's needed for this is probably more than we can handle with a small team. Right? This is why we are very reluctant to use anything that uses a driver. Having said that, it should be very straightforward to plug a third-party memory collecting solution into, let's say, FleetSpeak. Just call it from there, collect the memory using FleetSpeak, and go. Right? So we can probably easily support that. It's not going to be much work. But you have to realize that you're on your own. If your machine crashes, it's not GRR's fault.
Right. It doesn't count as FleetSpeak crashing your box. If the memory collector you run from some Joe's memory collector shack blue screens your box, I refuse to take responsibility for that.
Okay, so there is a question: if we wanted to keep recall around, then we would need someone to take care of it. And the question is also, is Michael Cohen no longer working on recall? So let me quickly summarize the situation with Michael Cohen and recall. Michael Cohen has left the team. He went to some other team at Google.
So specifically, he left the GRR team.
He left the GRR team, yes. And so recall was always his side project, essentially. While he was working on GRR, we gave him some more time to work on this. But at the moment, it's his weekend project, essentially. So he does some support. He still works on it, but he only works on it when he has time. And that is not a level of support that we can live with in a project like GRR. So this is why we have to put it into the experimental state. What's also happening is that Michael is now currently writing a recall agent, which is also the distributed recall solution, kind of. And he finds that very exciting, which is cool because the agent is cool. But at the same time, it also means that it takes away from the time that he has to work on recall memory forensics. So that makes the situation even a bit worse, I would say. Yeah. Or on PMEM for that matter. Same situation. PMEM is basically unsupported, I would say.
Yeah. But I mean, at least there's no time invested into its testability and maintainability, I would say.
Yeah. So summarized, I would say that the possibility of recall coming back into GRR is not too high, I guess. The chances are not too high for that.
Well, we don't have the resources to make it happen.
We don't have the resources
to make it happen. In the sense that if recall or another memory analysis framework became in a state where it was reliable, I think we could revisit that. I think we should if that happens. But at this stage, it doesn't appear to be supported at a level that we find usable.
There is actually some long-term plans in the Google forensics team to have a recall-like memory forensics tool. Basically, a small rewrite of the core functionality that we use and to put it into Plazo at some point. But resources, are hard to find. So
no promises on timeline.
No promises on timeline.
No promises
exactly.
whatsoever, but especially on timeline. On the
Exactly.
timeline.
Turns out that our forensics people also want to use memory forensics, so they are very unhappy about the situation. But what can we do? Okay. Good. I think this is good for today. Thank you everyone for watching. We have to do it. Bye.